All right. Hey, how's it going, everybody? This is Rudy McComb here, founder and CEO of ThnkBIG Technologies, and just coming to you live on this Friday, February 9th. It's about 2:34 here Central Standard Time, and wanted to do something a little bit different. Normally, we send out our weekly Cloud Drops weekly newsletter, which is a newsletter of the top stories that are going on in cloud native. And let me turn my monitor off here. The top stories that are going on in the cloud native world. And this week, we're trying something new. Seeing a couple of our colleagues and mentors go live, but we're going to do it a little bit different because we're going to use this as an open forum for discussion around Kubernetes. And more importantly, today, talking about containers, right? What are containers? Why are they important? Kind of give a history lesson about containers. And hopefully, you'll leave this session with more information about why containers even exist. Maybe you are new to the space of cloud native. Maybe you're new to IT. Maybe your company or organization is going through a current digital transformation and you are moving from a monolithic architecture on-prem or cloud, and you're moving from VMs, and you want to go ahead and take advantage of containers, and you've been told by someone on your team, or you heard from a colleague that containers are going to solve all your problems, and that containers allow you to go ahead and run this other cool technology called Kubernetes, which also solves all your problems. And so I want to go ahead and shed a little light on the subject. But again, my name is Rudy McComb, founder, CEO of ThnkBIG Technologies. Our purpose, our mission is to help businesses like yours succeed with cloud and cloud native. If you are struggling to get your dev and your ops to work correctly, if you're struggling getting your applications to scale properly in the cloud, you're struggling to understand Kubernetes, whether it's EKS, AKS, GKE, COPS, RKE, you name it, Tanzu, we can help you solve that problem. We are all US based engineers, no offshoring or nearshoring, and we're based here in beautiful Austin, Texas. So let's jump right into it. I prepared a little bit of a slide deck, but we'll start this conversation off with talking about, hey, what are containers, right? And let's kind of take a step back and walk through, the purpose of containers at the end of the day is to be able, using a real world example, to be able to take any kind of product and shove it inside the container, and then the container in the tech world, it will be the container with something like ECS or Kubernetes, but in the real world, containers are put onto ships and they're shipped from one point of the globe to another point of the globe. They're put on rail, they're put on trucks, and those containers can hold any kind of product. This could be anything from a chair, a car. Sometimes could be a small component of a house or even a tiny house. Could be solar panels, whatever you think of can fit inside that container. And the contract, if you will, is that the shipping company will go ahead and take your product as long as it fits inside that container and ship it to wherever you want it to go. And so containers serve that same purpose in the tech world inside of IT, and they allow you to ship your code. But that code, not but the code is basically it could be anything. It could be a front end application. It could be a database. Could be a web server. Whatever you think of. So let's kind of step through the application delivery model, and let's talk about some of these models that have existed so far. So let's go ahead and switch on over here, and let's talk about it. So why containers, right? Well, first of all, containers are deployable units, right? And these deployable units are used by different orchestration frameworks like Nomad from HashiCorp, Kubernetes, Netflix, Eureka, uses them for service discovery, and then AWS, used as a cloud provider to serve those containers out. And actually, I'm going to switch from this one over to another slide that I have here. This one is going to be better. Okay. So as we're stepping through and talking about the different application deployment models, let's talk about how things used to be, right? When applications were deployed prior to containers, prior to virtualization, you had on-prem. And on-prem applications are applications that were installed on your Red Hat, your Ubuntu server, your Windows server. And what would happen is these servers would come up, and when these servers came up, basically there would be some sort of a kickstart or a pre-seed that would happen. And when this would happen after the server comes up and it's booted up and all of its base processes and whatnot, and services are up and running and systems. And then this Kickstarter pre-seed would run. And then after that, what would happen, a config management tool like a Puppet or a Chef, Ansible or a SaltStack would then do further configuration, right? It would be used to install different applications, but more importantly, these configuration management tools, which really saw their heyday around, say, 2013 or so, up to 2013, 2014, 2015, these tools would go ahead and prevent drift. And they would prevent drift on the files, it would prevent drift on the binaries, whatever you wanted to prevent drift of and make sure that these configurations never changed. That's what happened. So once those came up, you would have a fully configured server, and your server is ready to go, right? So if this is your web server, then you're going to go ahead and have, Apache, and Apache's been fully configured. If this is your database, you're going to have your Percona, your MariaDB, MySQL. That is now fully configured. And then you have your application server, right? So if you're using something like Java or whatnot, then that's going to go ahead and be configured as well, all right? And typical web applications are going to be based upon some variation. I like to keep it simple. I use basically the LAMP stack, right? So Linux, Apache, MySQL, and PHP. Pick your poison: PHP, Python, Java, whatever. And so basically, when your server came up, you would have these three distinctly different servers that have been fully configured. And they were so cool because you could turn the server off and turn it back on. And the pre-seed script would ensure that everything is already there, right? And that the server service is already up, the IP addresses are there, whatnot. And then the configuration management tools, they would go ahead and check, are all of your hosts, etc host files are correctly written. Your temp location has the proper permissions on it. Are these bins and libraries already installed? If your servers were in a air-gapped environment, then in that case, there would be a local repo where these config management tools would do an apt or a yum installation on these servers in order to go ahead and make sure that the versions that you needed for the application to run were there and installed and at the ready. And that is how, for the longest time, on-prem applications and services were provided to internal and end user customers. And this still happens today as well. This still goes on today. If you're in an on-prem environment and you're not using, any type of cloud, and you're not using any type of virtualization, this is how it's done. Even in the world of Kubernetes on premise, this is still how it's done, right? You'll have your pre-seed, you have a config management, more likely today Ansible. And then Ansible will go ahead and configure the Kubernetes nodes, if you will, in the masters. So let's kind of step on through the diagram again here. Here's the web servers, here's the application servers and database servers. And then, here are the different packages, right? So Base OS is already there. Your pre-seed core packages are there, and then you're going to go ahead and have configuration management, tune, and finally set your permissions and install additional services that are needed, especially on your libraries and frameworks for each of these servers. And then also configuring your networks, your different ports that need open, right? 3306 from MySQL. If you need 443 for certain front ends for your application, whatever that is, those will be configured by config management, and those will get mapped to the network ports, which you could even use those tools to sometimes configure networking inside of an on-premise database or on-site, not database, but on-site data center or off-site data center. And that is what your traditional architecture would be for what we'll call Model 1. As we kind of step through, let's talk about the problems with this. Well, the problems with this is that you have very expensive front, middle, and back end servers and services, right? These were not cheap. You had to go ahead and procure racks and servers from HP, from Dell, and then you had to make sure there was sufficient capacity to handle the load. You had to do a very good calculation, very deep research into understanding what are the highs and the lows of this application, right? Is this going to be a publicly facing application, right? Are there certain times of the day or night where customers are going to be hitting it, or is this going to be something that's internal and maybe it's going to run a batch process in the middle of the night, so it needs a certain amount of resources. And because you can't just go out and go add a server in the middle of the night when no one is there, you had to go ahead and purchase what you needed ahead of time and then use it. And when it's not being used, not use it. This also led to another issue of tightly coupling, where your servers had a specific purpose. Every server had a job, and there was no such thing as just a spare server. If you were, doing proper budgeting and whatnot, and of course, as IT leaders, CIOs, CTOs, VPs, directors, managers of infrastructure and operations, your job is to ensure that you are purchasing exactly what you need and not too much over. Maybe you have a little bit of room to grow, but you're not going to under purchase, right? Even down to networking equipment, right? You have an F5 sitting there. That F5 has a purpose. That money wasn't spent just so it could sit there and take up space. And then, we talked about scalability, but again, just think about, well, what happens to those servers during downtime? Nothing's being done on them, so they're just using power. They're using air conditioning. They're using electricity, right? And they're using this just to be on, right? Not taking any load, but just to be on. So, other thing about this methodology is your deployment times are very, very lengthy, right? If you're in a DoD space, you understand what I'm talking about. Time to deploy an application, you had so many things that had to be not just clear from a security standpoint, but cleared in terms of, do we have the right hardware? Do we have the right capacity in order to host this application, whether on or off site in this data center, on premise? And if we don't, or it's already being spoken for, how long is it going to take for us to get that server, right? How long is it going to go ahead and take for us to get these racks? Who's going to install them? We have to go ahead and reconfigure networking, possibly if you're a very small business in the closet, if you're a medium-sized business or a large, enterprise, who's going to go down and go down to the data center and do all this? When is this going to happen? This would take weeks, months, depending on what the application is you're planning. Q1 2024 for something that won't happen until Q4 2024. And there's a large amount of difficulty in also maintaining this on-premise data center. So as we step through to the second model of modern application deployment, right? we get into the early 2000s with the advent of virtualization, right? And virtualization basically came about because the traditional way, while it worked, there were all of these advances in technologies and chip designs and processors and whatnot that allowed for compute, memory, and storage to be virtualized on one host. And if you can think of being able to take your, laptop nowadays, if we want to go ahead and install something, we go ahead and you'll download it from, download an image and wipe it out with a thumb drive. Well, not too long ago, we had CDs and we would pull things down from a network server or whatnot, and we would completely wipe out the PC. This same process would not persist once you move over to virtualization, right? And basically, what ended up happening is you would have a bare metal server, those same three servers we talked about before, right? RHEL or Ubuntu or Windows. Now you have a hypervisor in the form of VMware, right? And you have this hypervisor, and this hypervisor is controlling and managing all of your VMs. So the application server that you had a dedicated purpose for, this now can run all three of those servers, but virtualized, right? So imagine you had the application server. Now this is just a VMware server, and this VMware server has VM App O1. That's now your virtualized application server, and then you have VM DB01, and you have VM front end O1 or Java O1, right? And these virtual machines will still be tightly coupled, but not as much as before because at the end of the day, as long as you had enough memory and CPU and storage on the node, on this bare metal server to run the virtual machines, then you could share that across those three virtual machines, right? And they would go ahead and function just as before, right? A lot of times an end user would never know the difference that you just migrated from on-premise to a VM. And then those applications at the end of the day would be deployed on that guest operating system. So let's take a look at the architecture here, right? So as I said, this rectangle, if you were a square, this will function as the actual node. And then here's the hypervisor, right? And then this hypervisor, right, here's VM, and we can go ahead and change this to VM app O1, right? And we change this one to VM DB O1, and we'll change this one to VM. Let's try this again. It's always great when you're doing it live. VM Java O1, right? Or you can call this front, right? O1. We'll change this back to Java, right? And we'll do JV. That's fine. So again, I didn't pick these in order to match specifically, but for the purpose of this exercise, right? This particular VMDB01, right? This, of course, is the database here. Let's move this over. And then this one is app01. All right, so we'll take this, copy this over. And then here we are with JV01. Okay. And this is our application, right? So you have a specific VM for a specific purpose that has virtualized its CPU, its memory, right? Its storage, right? And you have the entire operating system is now virtualized. You have all the packages, all the libraries, all the binaries that are needed for this specific server to run, and it can now talk to the other VMs, right? You can update the etc host file on this VM and do the same for the app01 and DB01, and they would function just the same. And again, at a very high level, right? We can get into virtualized networking and a whole other topic, but at its high level, they would know about each other just like they would on-prem. right? And then this is how technology and application delivery advanced through the early 2000s. And while this was really great, right, for efficient use of hardware, right, and you had one single physical server that's running all of this, and you have reduced overall costs, and you have accelerated deployment, you have scalability that's improved. Why? Because you can come here, right, and you can literally just how I copy this, you can go ahead and copy this whole thing out. So, all right, I have one. Give me, well, in this case, I had two. Now go ahead and give me four. And this was essentially what you were doing, right? My VM admins, my VMware admins, you understand what I'm talking about. If you are unfamiliar with this, you can watch plenty of YouTube videos on how to do this. But this is how you would copy VMs over. And then there would even be storage units that you could purchase that would house storage for the VMware environment. Um, One great thing about this would be that this was now cross-platform, right? This started us to move in the area of agnosticism when it came to what OS are you running. It became more of, hey, we have a VMware environment. Just go ahead and give me a VM, right? It really didn't matter what it needed outside of the application function, but this started us moving in that direction. But the downsides, right? The virtualization downsides were that these VMs were not portable. Why? Because you're talking about an entire operating system that had to go ahead and exist while virtualized. It was still a whole OS. So you're talking about something that was around the magnitudes of 100, 200, 500 gigs, maybe a terabyte per VM, right? Something that large is very heavy, but it's also not portable. It's very difficult to move from a data center to another data center, at least in today's mentality, without a number of other things that you needed, right? Are you using tape backup? So, how many petabytes of storage do you have? And it just got unwieldy. Also, I will point out a lot of the VMware teams, right? They were so busy keeping this virtualized infrastructure up to date, your deployment time and creation of a VM took sometimes weeks and months, right? You didn't have to go out and order, but you still had to put in a request, right? And they had to get to it. It wasn't, some words they had a self service, but that was not the norm at that time. So, but now let's step over to the third model of application deployment, and which is a containerization. And in containerization, you have basically one host, and this host is running a container engine, if you will. And this container engine would allow you to go ahead and consume public containers from, say, Docker Hub, whether this is a Ubuntu container, this is Apache, this is a Core OS container, but that container is not an entire operating system. Containers function a little bit differently, where they basically allow you just to only have the libraries and binaries that you need for that specific function, and that's it. You didn't have to worry about, well, now I have these Office applications that came with this operating system. That's not on there. You didn't have to go ahead and install an entire OS as in a VM and then start deleting what you didn't need. No, you built it from the ground up with only what you needed. And this made containers very lightweight. This makes them, because they're lightweight, very small in size, and also very portable. And so if you can imagine coming from this architecture to this, where you have your web server, your app server, and your database container. And this here, you would have we'll call this, it says DBMS, but we'll call this Maria, right? And that's a Maria container. Here is your your Java container, and then over here is your web server. Um, and so you would go about and have these containers, that have specific, very discrete roles, and you could move them wherever you want to. You could start this, build this container on your laptop. You could then move it over to um, dev or test, right, your environment, and it will function the same. Why? Well, because the container is not dependent upon the underlying hardware. All it needs is the container engine in order for the container to run. The core packages of the operating system are relevant to the packages that are needed for the container to run. As long as those core packages support the underlying container engine, that's it. And so began, circa 2013 or so, this revolution or re-revolution, I'll get to that a little bit later, of containers and modern IT application deployment. 2013, a company called Cloud, they came out with this revolutionary technology called a Docker container, right? And Docker was this tech that allowed you to do this exact same thing, right? While Docker was not the first foray into containers, it was certainly at that time the latest. And due to where we were in IT and technology, it opened up and it basically lit a fire across what we now know as the cloud native landscape and architecture. So let's talk about some more of these benefits. So lightweight, they share resources from the host in which they run, similar to a virtual machine, but all of these resources, right, they're not virtualized, they're actually using that bare metal resource. Manageable. A single entity where an application, libraries, frameworks, and dependencies reside, right? Again, the container only cares about itself. It doesn't care and it doesn't even know about the other containers. And that's kind of the beauty of it. It's distributable and portable. Container is the way you move these around. You move these around like you move any other bit of code. You put it in a registry, right? You have registries like Docker Hub, like K, which is now owned by Red Hat. In the early days of cloud providers trying to create their own registries, early days, they have these registries now, but early days they had less features. But you have ECR, right? ECR for AWS, ACR for Azure, GCR for Google, and today you can even utilize GitHub to hold your containers. And then you'll pull those containers down. Now, some of the drawbacks, and it's not necessarily a drawback of a container, but once you start getting into the container registries and how you distribute the containers, you have to be aware that if you're getting a public container, these public containers most of the time are not secure. These containers are written, of course, by open source, and they're written to go ahead and add features, but they're not necessarily written to patch security. And while that has changed, and you have many different options out there, from cryo to Docker to Flatcar Linux, even to DistroList, which I believe is from Google, you still have to make sure that the container that you have, you pulled it from public, you need to go ahead and do your due diligence to scan that container. And one of my personal gripes when it comes to container registries, and while I will say today, container registries provided by the cloud providers have come a long ways. One of my biggest gripes is that a lot of these registries are not configured. If you're running them on yourself, they're not configured appropriately. And what I mean by that is some of the basic features, right? I'll go ahead and jump on JFrog. JFrog, awesome company, great engineers over there. But a lot of the organizations who tend to run JFrog are very large, behemoth organizations, right? Very bureaucratically entrenched. But the orgs that are responsible for managing JFrog, they're not turning on basic features, even in 2024. Features such as scanning the container, um, X-ray is not on from day one, right? What are we doing? Why are we allowing whether internal or external containers to be checked into the registry and they're not scanned at all? there are some organizations where basically there's an Excel spreadsheet that may have some information on it about a scan, but X-ray is not on from day one. It's ridiculous. Some of the one of the better container registries out there, Harbor, my favorite. Harbor came around circa 2018, developed by VMware, not VMware. Well, actually, no, it was developed by VMware China. Harbor was one of the first uh, on-prem. You can go ahead and deploy it in Kubernetes and have your own container registry as an alternative to Docker Hub. Harbor had container scanning from day one. It was always there. It was always being scanned, right? Harbor started off, and I think to this day they still use Claire for their container scanning. But let me actually, while I'm talking, let's kind of take a break. Let's go Harbor. Go Harbor.io. There we go. So here is Harbor. And this is the Harbor project. It's a CNCF project. And if you kind of look through the docs, you see the different versions that are here. You'll see, so many features that a lot of cloud providers they're still trying to catch up and keep up with Harbor. Harbor has a wonderful community, right? And everything from the administration side to different projects. Harbor can also host Helm charts, right? There's just so many cool things that Harbor does when you compare it to something like JFrog. JFrog is not in the same category as Harbor. I wouldn't even put JFrog in the same category as some of the cloud providers. However, if you're in secure spaces, if you are in the public sector, if you are a large behemoth organization, probably have been in this container space for a while, or maybe, Artifactor's has been there, then, you're going to have that JFrog product sitting there. But please make sure that you've turned on X-ray. You're doing daily scans. One of the cool things about Harbor, and let's kind of see if we can pop in Claire here. Let's see. Here we go. Default installation, import. Let's look at chart repository. Yeah, we'll do this. So the default installation without Notary, Clear, or chart repository. Notary allows you to go ahead and sign your containers. This has been in Harbor since, again, 2018. Notary is I want to say it's a Docker adjacent project that allows you to create a signature for your container. And then when you check it in, you know who went ahead and pushed this particular container, right? For security. Claire is an open source tool that allows scanning of containers for vulnerabilities inside of Harbor. You can go ahead and set this to low, medium, or high. Here's the information about the Claire project from CoreOS, which is also pretty cool. And CoreOS has been absorbed, it seems, by Red Hat. Um, but yeah, Claire is an open source project which provides a tool to monitor the security of your containers through the static analysis of vulnerabilities in APPC and Docker containers. Claire is an API-driven analysis engine that inspects containers layer by layer for known security flaws. Using Claire, you can easily build services that provide continuous monitoring for container vulnerabilities. And you can read all about this over here at Red Hat's website. And I'll try to go ahead and make sure that that link is tossed in the description section of the video. Um, but how Claire works, Claire is going to check its inventory of packages and match those against known CVEs. You can set how often the frequency that you want Claire to go ahead and scan your containers, and then it gives you a report. Now, the cool thing about Harbor is that Harbor, if you set the threshold to low, medium, or high, you can tell Harbor, do not allow this container to be pulled if it reaches a certain threshold, right? And in a lot of our clients and whatnot, and the organization we worked in, this has been very advantageous because it allows us to go ahead and approach a customer and say, hey, we have this, what we call the base level of security within your Kubernetes and cloud native environment within your platform team. And no matter what you write, if all of your images are being pulled from this Harbor container registry, then you're going to ensure that only containers that have passed, or only have a certain threshold of security or insecurity, and depending on how you view that context, are going to allow to be pulled. Now, that can also lead to deployments to pods crash looping, not being able to pull the image because there's now high vulnerability. But you can do things with NATs and do things with, I want to say Covert, but with NATs and I want to trying to think of the serverless. Kubernetes CNCF project. But there's a couple projects where you can go ahead and have Kubernetes execute an API call on itself, so that way it can either remove a node or it can go ahead and add a node to the cluster while you go ahead and isolate that particular troubled container or application or deployment. Um, but these are some of the features that Harbor gives you from day one, right? And it is again probably the what I would consider the gold standard for container registries. And again, if you are in the Red Hat shop, or if you're unable to, if you have to go in that direction, Red Hat has K, which is also a fine product as well. But I would say, even if you're not going to be using Harbor in your environment, take a look at it, right? Take a look at it, see what's going on with Harbor, get an idea of what they're doing, and you can kind of compare that to what you currently have, and have those conversations with those teams. So let's jump back over. Got a little bit of time left here. Let's jump back over and finish up our conversation around containers. So, as we said earlier, containers can be distributed very easily. They're smaller than VMs. They boot in a matter of seconds. Um, they are extremely cost effective, right? Better use of the resource and underlying host due to the lightweight nature of the container. And they can also run, there we go, I lost my place. You can run thousands of containers on a single host as opposed to hundreds of VMs on that same host. And let's see here. There we go. Um, so within this, this is how modern applications are delivered. This is, what we consider normal in today's world. This is how you get the HBO applications that y'all get like Max. This is how you get the Disney Pluses. This is how you get the Paramount Pluses. Applications on your phone, airline apps, United, American Airlines, Delta, they're all running containers. And every day it's a constant, not struggle, but every day they're trying to get better and better with efficiency, right? How you write the container. Are you duplicating your layers? Did you just copy paste from somewhere in order to have these layers inside of your containers do what they need to do, or are you discreetly making choices to make sure that your containers are as thin as possible, and so they run as efficient as possible? Because the better that they run, then the better Kubernetes is going to go ahead and operate those pods. Let's talk about quickly use cases. Problems, right? Code pipeline. Each environment in the pipeline may have subtle changes that can lead to breakage. When it comes to containers, right? You develop this on your laptop, your Bastion host workstation, right? And then you move it over to your dev environment, integration, test, QA stage, and then production. Um, while it says the package and the application stack into a container and shipping that through the pipeline that runs the same at each step, regardless of underlying infrastructure. I wasn't going to throw the slide out, but I wanted to highlight this because a lot of times when you have, something as lightweight as this, well, where's the problem? The problem is going to come in your pipeline, and your pipeline, it's not going to be discrete if you have people stepping all over each other. Again, if you are, new into CI/CD and you are not really understanding the purpose of continuous integration, continuous deployment, you will have one pipeline doing 50 million different things, right? And you have organizations where you have an engineer who is responsible for building this pipeline and that pipeline, and the pipelines have errors. You may go ahead and run your container, and you've made your change to your application, the container gets built, but when it hits the pipeline and does a test, you find out, hey, out of 5,000 tests, which is just asinine, you have 900 errors. Well, your container cannot go ahead and pass because you have all these errors all of a sudden. Well, it works on your laptop. It works in your Kubernetes environment that you tested this in, but you put this in another environment, and these tests have ran, and then you have all these errors. Well, upon further investigation, it's actually not your issue. It's the pipeline. That's the issue. And you have, bad actors. You have engineers who are busy, right? Busy fixing things, but you don't have a commitment to excellence. And when you don't have a commitment to excellence in your IT organization, then you're going to have various areas where issues shouldn't arise. Then there are issues there, right? Um, I've had the unfortunate pleasure, but of course, it's all experience. But I've gone to orgs where you have the speed of delivery that's being hindered through poorly designed pipelines. You've had weeks added to your deployment because of 600 errors, right? This person has known, this engineer, this team, this unit has known about these errors, never fixed them. Why? Fixing is not what they do. And, kind of coming down to, well, what's the point of all this conversation about application delivery models? At every stage of these previous models, um, for every advantage that technology would give us, right? Whether it's traditional on-prem three-tier architecture, or it's a virtualized architecture, or we're talking about the containerized architecture, technology will not save your organization from itself. I'm going to repeat that again. No technology will save your organization from itself. If you have IT leadership, that is not technical. They're there to go ahead, sign off, press a button, to go ahead, sign off, get their bonus, right? They committed to something that they don't even understand. They've been told that it's beneficial. When you peel back the layers on that onion, because they don't know, they've given that task to someone else who does not know, and they're also just doing the bare minimum. You can hope, you can pray, you can do whatever you want to, but there has to be a commitment to excellence, and you have to be committed to actually understanding how this works. So many times, right, some of our most critical infrastructure, whether it's again defense, healthcare, whether it's utilities. A lot of this stuff, a lot of these applications, they're just rushed through, told, to a higher that this is signed off, or told that this works. But when you look at it, you can't go ahead and push a change at 2 o'clock on a Tuesday without it breaking. Why? Because none of your stuff, none of the supporting pipelines and work. Your containers are bloated. Your Kubernetes clusters are not isolated. There's just it's the equivalent of going to a kitchen and seeing a chef chop your onions, flip your burger, work the cash register, sweep the floor, and then bring you out your food with those same hands. There's no cleanup. There's no tidying. There's no commitment to, hey, do this task, make sure it's done correctly. And you have plenty of people, but again, the direction from the top is affecting the bottom. And you also have the inverse where you have You know, I'm not going to call them bad actors, but irresponsible contractors, irresponsible entities who come in and they've sold your company on being able to get this done, but they did not walk through each step with the same level of responsibility as they should. And so, yeah, you have an app, but you could not push a security change to save your life, and not in any kind of quick turnaround time. It's going to be weeks to go ahead and do it, and you'll constantly get excuses in these situations. So as we're coming down here to the about 3:30 Central Standard Time, want to go ahead and kind of wrap this up here. There's more information I have in the slide deck. I'll go ahead and publish this, and we'll get into a conversation another time about the history of containers. But just wanted to have this overall, high level overview of what containers are, what they do, why they're beneficial, right? And why you should use them in your org, right? Um, as we're coming to a close, again, my name is Rudy McComb, founder and CEO of ThnkBIG Technologies, located here in Austin, Texas. Our engineers, we are here and ready to serve you. All right, we want to go ahead and help your org. We want to see you all win. We want to help you overcome those hurdles, those IT challenges, making sure that you can deliver your application as quickly as possible, ship that code faster, and also have fun, enjoy the process, learn, grow, right? Make sure you get the maximum return on investment. Make sure you're not spending too much on the bits of technology that you have, and make sure that you're maximizing all the technology resources that are at your disposal. You can go ahead and find us on all your social media platforms. On X, you can find us at ThinkBig, THNKBIG.com, or THNKBIG. Our website, THNKBIG.com, ThinkBig. You also find us on Instagram and Facebook at ThinkBig Tech, THNKBIG and give us a call. If you'd like to have a conversation, we'd love to talk to you. 512-706-9553. More than happy to help you. Again, my name is Rudy McComb. Pleasure talking with you today, and I will see you soon. Thank you and take care.